Hello everybody, welcome back to our part 2 of factoring quadratic equations. In this video we're going to talk about factoring quadratic trinomials in particular, and we're going to take a look at some of those examples shortly. But first what I want to mention is the standard form for quadratic equations. That's what this unit is about. We're talking about quadratics, whether graphs or equations, and the way in which you want to rewrite your problems if you're ever given some other form. And a quadratic equation is as follows. You want to rewrite your equations to look something like this. Now, A, B, and C are important components here. They all stand for just different types of numbers you might encounter in your problems. A might be a negative number, B might be a negative, C might be a negative, or they might be positive numbers. They might be 0, they might be 1. All of these components, right, your coefficients for your variables as well as the constant at the end, stand for certain numbers, okay? And the goal is to try to find out what those numbers are. That's going to be especially important for when we use things like the quadratic formula, which we'll see later. It's also important for when we're factoring trinomials, as we'll see in this video now. But the goal is to always set up our equation to look something like this, where everything is set equal to 0 on one side of your equation, and in descending order you have your highest to lowest exponents with those coefficients made visible if you need to. So for example, x squared equals 8, that's a quadratic equation, right? It's quadratic because you have x squared, okay, degree 2. But it's not written in standard form, right? We need to have everything set equal to 0. Right now our equation is set equal to 8. So how do I get one side of my equation equal to 0? Opposite operations. If we want to move 8 to the other side of our equation, opposite of a positive 8 is a negative 8. So subtract 8 to both sides. That's going to cancel this out. And now we have x squared minus 8 equals 0. So we're very close to the form that we're looking for. But notice, right, in standard form, we have a middle term. Positive bx or negative bx, depends on the sign. In this case, b is like an invisible 0. 0 times anything is 0, right? So 0 times x, for example, is 0. And adding by 0 doesn't really change anything. What it does do is allow us in future problems to be able to label b, which is going to be important for when we're factoring today and when we use a quadratic formula later on as well. Notice that a here, the coefficient for x squared, is like an invisible 1. So sometimes you have invisible 1 as a coefficient. That can be a is 1, that's visible. In this case, b was 0 because it didn't show up. There was no x value here in this equation. So your coefficient must have been a 0. And lastly, your constant c, that's a negative 8. Don't forget that you include this sign with all of your coefficients. So it's not positive 8. We subtract it to both sides, that's a negative 8. That's our kind of start to where we're going to look at for factoring problems. So if you want to go to my Desmos lesson, I have a few more examples of how you would try to identify A, B, and C after rewriting certain quadratic equations. But we're going to use that information later to solve some problems that involve factoring. So I have one set up shortly that we'll do. But first I want to return to what factoring is. So in our last video we talked about how factoring is breaking down an expression into two multiples of the original expression. So for example, factors of 3 would be 1 times 3 or negative 1 times negative 3. All of those four numbers are factors of 3 because you can divide 3 by those numbers evenly. Likewise, you can divide expressions involving variables. You can break down expressions involving variables into 2 or more factors that could multiply out to give you back the original problem. So in our last video we talked about binomials mainly, and then some GCFs. We talked about the greatest common factor method of factoring. We talked about the perfect square pattern of factoring that we saw as well. Here we're going to talk about trinomials, and that's when you have three-part problems. So something like x squared plus 2x minus 8, three parts to our problems. These are trinomials. Okay, and they're also quadratic expressions as well. Notice you have that x squared there. So there's going to be two ways that you can try to factor these problems, and it's up to you which one suits you best. If you like one method, work with that one. If not, try the other method, or try both and then see which one, after some practice, clicks with you. One method that we can use is called the factoring by sight or box method. That's how I refer to it anyway. And the point is that whenever we're factoring something, right, we are trying to, and especially with variables, we're trying to break our answer down, again, to something that multiplies back out to equal the original expression. So with that in mind, I need to think about what could possibly be put inside these parentheses that would multiply out to equal this original problem. The first thing I'm going to do is think about what times what is x squared, and there's not really much that you can think of other than x times x is x squared. In other words, part of my answer must include x in my first parentheses and x in my second parentheses. Okay. Now I need to think about numbers, right? What numbers, for example, multiply to give -8? Well, there's a couple of numbers, right? Pairs of numbers that could do this. You could have 1 times -8, -1 times +8, 2 times -4, 4 times -2. And basically what we're going to find is that one of these pairs of numbers is going to be the pair that fits into the parentheses for our factored form. The question is which one? So what you need to do for the box method is try, test, which one of these numbers would work. So if I tried, for example, a 1 and a -8, what's that going to multiply out to be? It had better be my original expression, or else I have a problem. So for example, -8 times 1, -8, this is a good start. We want -8 to show up in our answer, right? However, x times 1 is 1x, and, excuse me, x times -8 is -8x. Unfortunately, combining these terms, 1x minus 8x, does not give me a positive 2x. So that cannot work. +1, -8, not my solution. What if I try -1 and +8? Just change my signs. Well, what you'll find is that this also will not work. Okay. Notice that 8x minus 1x, 7x, that also does not equal our original middle term, 2x, and that's going to be our goal. So this does not work as well, meaning I have to try either 4 and -2 or -4 and +2. Okay. Now some of you, again, by sight, might have intuitively thought that it might be better to multiply by, let's say, a 4 and a -2, and you would be correct. Okay. X times 4 is 4x, x times -2 is -2x, and if I combine these like terms, 4x minus 2x, is that my middle term? Yes, it is. In other words, this +4, this -2, fill out my factored form for my problem. This is factored form. I've broken down my original equation, or I should say expression. My original expression has been broken down into two multiples, two things that can multiply out, two factors of the original problem, and that is factored form. So if something by sight works for you, and clearly this could not have been the right answer, this is the only one that works. If that works out for you, if that made sense, if you see that x times x is x squared, that has to go inside your parentheses, as well as 4 minus 2 is 2, or 4 times -2 is -8. That's one way that you can factor quadratic trinomials. Another method that you can use is what's called the A times C method. So it'll be somewhat similar to what we just saw, just more structured. So for example, the A times C method asks us to identify what is A, B, and C in our original expression. So what we just saw, okay, is very important, especially for when we have equations. Make sure that you have standard form written out. If you have an equation here, okay, we're just factoring an expression. There's no equation to work with or worry about just yet. But A is an indivisible 1, B is 2, and C is -8. Now the A times C method tells us that we're going to multiply A times C. So what does that give us? 1 times negative 8 is negative 8. We're going to list, in our next step, the factors of negative 8. Again, what times what is negative 8? In this case, negative 1 times 8, 1 times negative 8. This should look familiar to what we just did. Negative 2 times 4, negative 4 plus 2. Sorry, times 2. These are all the factors of negative 8. The question now is which one of these adds to give b? Which one of these adds to give b? We've already dealt with a and c. We multiply those out. That's how we're going to incorporate those components of our problem when using the a times c method. Now we need to think about, out of all of these options, which one combines or adds to give b. The only one that's going to do that is this option here, right? 2 minus 4 is negative 2. We're looking for a positive 2. This is not correct. 1 minus 8, negative 7, not what we're looking for. Negative 1 plus 8, positive 7, not what we're looking for. Here, in this case, negative 2, positive 4, these are the numbers that I'm going to use in my last step. Because a is 1, and we're going to see what happens if it's not, but because a is 1, we can use a shortcut. And then we're going to see later, when is it not okay to use a shortcut? What does that mean? Here, we can use a shortcut. The shortcut is to say, we're going to take those numbers, negative 2, positive 4, plug them into parentheses. These are our factors of our original problem. And we're also going to include our variable in our problem. In this case, the middle terms variable is x. When we start factoring with higher powers, it's going to be very important to pay attention to what this is. For here, basically it's just going to be x. Okay, because x times x is x squared. Once again, this is the factored form. This is the same thing that we saw with the other method. If you multiply this out, it'll get you back to where you started from. That's how I know that this is correct. Okay, so 2 methods of factoring. You choose which one you want to do. Now, I'm going to give one more example. But this example is going to be involving an equation, so we're actually going to solve this problem. Okay, factor first, then solve. But also you'll notice that in this case, a does not equal 1. And this is going to be where I say that if the factoring by the box method works for you, I would probably recommend it. If the a times c method works for you as well, though, there's nothing wrong with it. It'll just require a different step at the end. You can't use a shortcut. We'll see why shortly. So, first of all, box method. So I know that I'm looking for 2 parentheses. This will be my factored form. And I have to think about what times what is going to equal 2x squared. Well, in this case, the only things that could be 2x times x will be 2x squared. You would add your exponents like an invisible 1 and an invisible 1. 1 plus 1 would be 2. 2x squared only can be the product of 2x and x. That's going to be part of my answer. Now I need to think about what else will I have? Well, whatever this last box is better multiply to equal negative 15. These two numbers better multiply to give negative 15. But I have some options here. Okay. My options, for example, factors of negative 15 include 1 times negative 15, negative 1 times positive 15, or 3 times negative 5, negative 3 times positive 5. So I have to think about what to plug in to these boxes that's going to combine. Remember, these boxes will combine, but they have to combine to give us 7x. So you need to test which one of those will work. Now, if you look at it pretty apparently, the 15 is going to be a little too high to work with, right? If I, for example, put, I don't know, 15 down here and negative 1 up here, okay, that's one option I could use. However, 15 times 2 is like 30, and that's way too far away from a 7. So that's not going to work. Likewise, negative 15 doesn't help us either. It's going to be negative 30. So right away, you can see that 15 should not go here. But what if it goes up here? What if I have a negative 15 and a positive 1? We're trial and error. We're using trial and error to test what works, and clearly this also does not work. 2 times 1 would be 2x, and x times negative 15, negative 15x. Again, you try to combine those, right? try to combine these things here, not going to give us 7x. So clearly, we're not going to be using anything that involves 15 as our factor. That does leave us with a couple options. Okay, so let's try, for example, the first combination, -5 and 3. Okay. Try it in this order, then try to reverse it. For example, x times -5, -5x. 3 times 2 would be 6. Unfortunately, 6x minus 5, that's 1x, not 7x. This does not work. Switch it around. What happens if I have a -5 and a +3 up here? Now x times 3 will be 3x. 2 times -5 is -10. And this is actually getting a little bit closer, right? It looks like it might work, but unfortunately 3 minus 10 is a -7, not a +7. What that implies is that you should try changing your signs. Okay? Make this to be a +5, make this to be a -3. What happens now? -3 times x, -3x. 2 times 5, +10x. Aha! 10x minus 3x, that's what I was looking for. 10x minus 3x is 7x. What this tells me, -3 should go next to 2x. 5 positive should go next to x. This is my factored form of my problem. Okay. This, and only this, will multiply out to give me my original expression on the left-hand side. To solve, don't forget, this is the same thing that we did last class, by the way. We're going to set each parentheses equal to 0. Okay, so x plus 5 equals 0. Subtract 5 to both sides to get x by itself. One solution will be x equals -5. -5 plus 5 is 0. 0 times anything is 0. One solution, we're going to double check that by graphing shortly. 2x minus 3, same thing. Set that equal to 0. Get x by itself by opposite operations. Okay, in this case you have to do two things. Add by 3, then divide by 2. That's the opposite of multiplying. Your final answer here, 3/2. Fractions can be solutions. On the graph, you should be able to see that as well if you were to graph this. Two solutions, your parabola has two real solutions. Both come from your factored form of this problem. That is the box method. Clearly, by the way, this option did not work. Only this option placed appropriately. Not -3 here, not +5 here. This option multiplied out. So that's the order in which we have to write our answer. Okay. So that's the box method. A times C method will get you to the same solution. Okay. Just takes maybe a little bit longer. But as much as I'm explaining this pretty much in like very thorough detail, as soon as you get the picture of one of these methods, it's very quick. Especially since this shows up not only in this unit, it shows up in unit 3 and 4. You'll get used to factoring at some point. It'll become second nature, or at least I hope so. So A times C method, again, you need to think about what is A, B, and C. Now in this case, my equation is written in standard form. That's very important. That's why we talked about standard form at the beginning of this video. A, coefficient of x squared is 2. B, coefficient of x is 7. C, -15. Don't forget that sign. There was nothing that was invisible in this case. Okay. So A times C method. That'd be 2 times -15, which is -30. We need to think about two numbers that multiplied to give -30, but add to give 7. So I could create a long list of numbers. For example, 6 times -5, or -6 times +5. Those two things multiply to give -30. Unfortunately, neither one of these combinations add up to give a 7. 6 minus 5 is 1, not 7. Can't trust that. -6 plus 5, likewise, does not give us 7. Try something else. Let's try -10 plus 3, and then 10 times -3. Both of these combinations, right? These things multiply to give -30. These things multiply to give -30. But do either one of them add to give 7? Well, not the first one, right? This is a bigger negative number. 3 minus 10 does not equal +7, it equals -7. That's not what we're looking for. We're looking for a positive 7. Okay. However, this works. Right? 10 minus 3 equals b, and that's our point. We want to find what combination equals b, what list of factors equals b. In this case, it was 10 minus 3. Now, in this case, a does not equal 1, so no shortcut. You cannot use a shortcut for this problem. The reason is, and let's try to think about what would happen if you did. If I had x plus 10 times x minus 3, okay, if I just plug those into parentheses immediately, the problem here is that x times x is not 2x squared. You can immediately see that this is incorrect. And if you want to try to multiply this out by, oh, let's just put a 2 there and see what happens. That's not going to work either, right? 2x times negative 3 is negative 6x. 10x minus 6x is not going to be 7x. This is not correct, so we cannot use a shortcut. Here's what we can do, however. Okay. We can take these numbers, these factors, and replace 7x in our problem with those numbers. So for example, I'm going to rewrite the problem over here and show you what I mean. Okay. I'm going to break apart 7x into 10x and 3x. Notice this is not anything that different from our original problem. I could subtract these if I wanted to get back to my original problem. But the reason I'm doing this is to help me do what's called group factoring. Okay. Notice I have 4 terms here now, right? 4 parts. This is where I can put parentheses around my first part and parentheses around my second part and find a greatest common factor in both. So notice in this first parentheses, the greatest common factor, the GCF, we talked about this in our last video, 2x. I can divide 2x from everything in that first parentheses. In the second parentheses, my GCF, what can I divide both negative 3x and negative 15 by? I can divide by a negative 3. Okay. Now what's going to happen is that you should see 2x minus 3 actually showed up in our answer earlier. Okay. Basically, the GCFs of each parentheses, put those together, that's going to be part of your factored form. Our answer will indeed have 2x minus 3. Okay. But we need to somehow find out how, from this method, do we also get x plus 5. And like we've done with GCFs before, you also not only want to find them, you want to take them out and see what happens when you divide by them. So for example, if I took 2x squared plus 10x and divided that by my GCF, what is that going to equal? 2 over 2 will cancel out. X squared is dividing by x. X squared over x is x. And then 10 divided by 2 is 5. X over x cancels out. Aha! X plus 5. That's also what we found earlier. That's going to end up being a part of my final answer as well. But you need to double check yourself. This GCF also has to divide from my other parentheses to equal the same thing. Let's test that. This should equal negative 3x minus 15 over negative 3. And it does, right? Negative 3 divided by negative 3 cancels out. X is left over. Negative 15 over negative 3 is positive 5. This checks out. This is my factored form of my problem through either method, A times C method or the box method. Either one of us gets the correct factored form. Notice you do need to set that equal to 0 and solve just like we did earlier to get the same solutions. But those are 2 methods of factoring that you can use for trinomials. Box method, A times C method. Either way, one way that you can double check yourself is to multiply out your factored form. Okay. The box method is already set up to do that. A times C method, just set up a box yourself and double check yourself that way. Another thing that I'm recommending is that you guys always graph your problems to see that those are the correct solutions. So, and the way that you do that is to go to desmos.com/calculator. If you type this into the graphing calculator okay, whether you have one of your own or you're using one online, what you should find is that you end up with a parabola that looks something like this. Okay. Now why is that important? Well, first of all, it tells us that we have two real solutions, right? We talked about this in our first video for the unit. Two real solutions because it hits the graph twice. Specifically, however, it's the solutions that we found earlier, right? You're going to find that this x-intercept is going to read as, I think that's 1.5, yes. It'll read as 1.5 comma 0. That's the same as 3/2. Leave it in fraction form, but the decimal means the same thing. And the other x-intercept over here is going to be -5 comma 0. That's the other solution we found earlier. Those are our roots, zeros, and solutions. X coordinates, x values equal -5 and 3/2. Two real solutions. So many ways to go about double checking yourself in this unit. Use all of them to your advantage. Graph all your problems, I would say. That's very simple way to double check yourself. And make sure that you're multiplying problems out to make sure that you have the correct factored form as well. Always multiply your problems back out to check to make sure, once again, that this takes you back to your original equation or expression. And that is it for this topic. So we'll come back next video and talk about completing the square. And then after that, the quadratic formula, and that will wrap up the unit actually. So I will look forward to seeing you then.